So I was at an event back in February, end of February I think it was, and we're going to talk about mobile security. I was asked, I like to do the events, I like to talk about something, spread the knowledge, spread the word, and I did this talk on mobile security, and I said, oh yeah, I'll put my slides online later. And I was reviewing the slides, and I realised that maybe these slides don't quite make sense without a bit of narration going with them. So what I thought I'd do, instead of sitting here and talking about just put the slides online and then people reading through them, because they're not really slides you can read, they don't really come across. So I thought I'll do a quick recording, put them online. One thing then to another, work, drill, all the rest of it. I never got around to recording it. So this is the recording of basically the presentation I did in February, with a bit more feedback, a bit more spread out, because I to be honest with you, I crammed too much in. I was 40 minutes and I was like, I put too much into it, and I wanted to spend a bit more time talking about some of the elements. So I hope I could cover everything I covered back in February. There may be a few bonuses as well. There may be a bit of feedback I've got back afterwards which I wanted to cover off, and some extra knowledge I know about some things that I didn't mention on the day. I'm also just a little bit wary that at the time, I work for a company called Proxama. I've worked there for nearly 10 years. There was a small H in the middle why I didn't work there, and I also do a couple of startups on the side. So this isn't on my usual Imperium channel, although there's a lot of coverage. So one of the things I do at Proxama, I have done at Proxama, is I work for the payments division of Proxama, and we know a lot about mobile security. There's nothing in this presentation which is really secret. There's nothing which is IP of Proxama. This is all pretty public knowledge, but I've tried to condense it and bring it down into, these are a bunch of best practices people should be doing, anyone can do, as well as towards the second half of it, here is some stuff you do if you're trying to go beyond the curve. So I'm going to talk about Whiteboxes, I'm going to talk about trusted execution environments, hardware-backed security, things which an average mobile developer probably isn't going to touch, but to give you kind of visibility of what you could do if you had to. So all that's coming up in the next, however long it says in the video, however long this actually lasts for. Alright, so first of all, incredibly beautiful presentation. I did splash out, I think it was 20 quid or so for a nice PowerPoint template. Actually, I think it's PowerPoint template. All the images in here, apart from a couple, are from Pexels, and they just look astounding. So anyone doing these talks, I would recommend doing it. Very, very quickly, I want to talk about Nordevcon. Nordev is a community of developers in Norfolk. It is run by a couple of volunteers. And they run a conference every year, and it is amazing. We've been several times now. I think I've talked on at least 2 of them. I'm their just the minute champion, reigning champion now for 2 years. A technicality of why I'm there for 2 years, and it's a great thing. It's a great way of meeting a developer. It's a great thing to get those skills back. You basically turn up and say, I take the intern. We have an intern program. I take the interns every year. And they sort of sit there and go, Sato, what do you think? So, well, it's just stuff you've been telling us along. And say, yeah, but it's really great to hear it from other people. It's really great to have that energy and enthusiasm, and that to hear that what you're doing and what you're trying to do is the right thing. Because sometimes when you're dealing with people who aren't technical, you sit there talking about agile process, you sit there talking about testing, you sit there talking about, and there's a lot of resistance saying, no, well, we just want to ship product, we just want to ship product. And then when you go to these events going, yeah, the right thing to do is agile process, the right thing to do is look at peer programming, the right thing to use is the right kind of technologies, and push for these things because you make better products. And it's great to have that enthusiasm and the passion which you get across. So Nordevcon, if you haven't been before and you're in the Norfolk area, I say Norfolk, people come as far as Reading to this thing. People come from Scotland to this thing. It is an amazing community event. It is an experience. It's on for 2.5, 3 days if you go to the pre-day, first day as well. They have a day where school kids turn up. It is just astounding. So as part of being part of the community, we do a talk, and so I was said, oh, what do you want me to do it on? I said, oh, mobile security. I'd rather do it on another product, but we said mobile security, that's what I'm supposed to know about. and I'm supposed to know about it because it's kind of my job. Okay, so mobile security. This particular talk, if I can make it go on to the next slide, which I can't because here we go, is going to be there's 2 jokes, and I forgot what the first joke was. Oh no, it's coming up on the next slide. And then we're going to talk about some very simple stuff any developer, any average mobile developer can do. And then we're going to start talking about stuff which an average developer probably can't do. Not because they're not capable of doing it, but because they just don't have access to the tools. And it's not these are the kind of things you can't just go online and find out about. So either specialist, or you need to be handing over 5-digit sums of money to get access to the SDKs because it's licensed. Because some of the stuff is what we call enterprise level. You have to just basically know the right people and get access to them. So, as I said, my name's James Taylor. I work for a company who deals with security products, and I deal on that security side. So obviously this is a picture of me. This is what I look like. And it turns out my motto in life, I've always think when what's the tagline for myself? And at the moment it does seem to, what could possibly go wrong? Because we sort of push the boundary on tech. So working for financial organisations, a lot of them are very resistant to doing cool stuff. And you sit there going, oh, we're a bank, we're a processor, we have everything in the back office, it's not on the internet. And I turn around and say, okay, let's put a credit card on the phone. That means connecting your phone to this back office computers. And they sit there going, we just don't have any ability to do that. There's just no way the networks are joined in this manner. And you sit there going, okay, you have to work with these guys to bring these incredibly security conscious people and to say, yeah, I'm just going to allow these phones, any phone on the internet, to connect into this back office system. So when we start talking about pushing the boat out a little bit, on one side, I am seen as a little backwards in that I'm saying we've got to do things securely, we've got to do things right, you've got to add in checks and balances, the rest of it. But actually in my field, I'm seen as kind of this cowboy who's turning around and going, well, let's put credit cards onto mobile phones and do crazy stuff like that. So it's a really like, you sort of swing between these two worlds. The one world is the world that you guys are probably all from, where you sit there going, let's just build stuff, let's build cool stuff and push it out there. On the other side is this very conservative, very slow to progress, very risk controlled world. So it really matters when we talk about some of the security things that you take that in mind, that sometimes I come from this very ingrained security conscious background, and sometimes I'm going to sit there going, yeah, let's just do cool stuff. But I've done a lot. I've done mobile dev, I've done server dev. I would say I'm more of a server dev than a mobile dev. I'm actually not a developer at all. I'm actually banned from writing code. And there's no code. This is the first time I actually did a demo where I've not tried to show off code, and it's probably the first time it's gone really, really well. Mobile security. What is mobile security? The one of the things about mobile security is we must realize it affects a lot of people. So I tried to get a grip on what's the size of the problem, because my background is mobile banking apps. So when I'm worried about mobile security, I'm worried about fraud, I'm worried about identity theft, I'm worried about people using malicious applications to pretend to be the right application to carry out those things. When I looked into it, actually, mobile security is more than that. Mobile security is also about people stealing apps. We found that for games, for example, there's an 80 to 90% of players on paid-for games are pirates, or 80 to 90% of the installs are pirated installs. There's also a stat which I found amazing, which was of the top 100 paid-for Android apps, all of them are available in cracked form, where you can install them without paying for them. You might have to go onto a Sigwin phone or a Cyanogen mod phone or something like that, but they're all available, and that's the standard. Now, we'll go on to how people deal with that situation, but the top 100 apps basically were hacked. We also found that there was this amazing amount of mobile fraud going on, where people were making purchases, but then were doing chargebacks on them. So actually, when a mobile in-app purchase was done, what percentage were actually being cancelled later, i.e. what loss was there to the user, to the merchant. And the other stat I put on the end, it's not really a fraud stat, but it's an interesting stat, which is that 84% of users use the same device for personal and work. And this is interesting because when we start talking about cross-contamination attacks, when people are installing apps on their phone which may attack other apps they've got on the phone, if they're using their same device for personal and work, and you do want your people to carry their phones with them so you contact them, this is a real problem when you start having this mixed world. When you start saying, yeah, they might have dodgy apps on their phone which they're then using to store their work emails on, that's a real problem. So, what is mobile security? What is the threats to mobile security? Well, going over the sort of the main risks, we've basically boiled it down to these 5 problems. The first one is data disclosure. So, via a mobile issue, are you losing information to your about your people? And we start talking about things like end-to-end encryption in WhatsApp was added quite late into its life cycle. We're talking about if I'm able to log on as another user, if I'm able to have an app which talks to Facebook messaging and download your personal information, is that a problem or not? Then we've got the idea of privacy. Loss of sale and fraud kind of goes hand in hand with each other. Loss in sale is one is someone had an app and they haven't paid for it. Or fraud is potentially grabbing someone else's app or grabbing someone else's identity and getting access to their bank accounts via an app. So there's a little bit difference there, but they can be very similar. So when other people talk about fraud, they may be saying they're fraudulently getting an app rather than committing fraud with an app. Whereas loss of sale is actually if an app can be pirated, or if you can go into an app and acquire paid for items inside a game or inside or whatever, then that can have a impact obviously on the people making the app. Brand damage is pretty big when an app gets hacked. If other people then decide to stop using your app. There's actually a really bad case of this recently in The Guardian, and Guardian published quite an in-depth technical attack saying that WhatsApp could get people using WhatsApp could lose their chat. Someone could impersonate them and grab their chats or take over their chats using a backdoor method of recalculating the keys. WhatsApp came out and said that wasn't true, and it looks like The Guardian in this case was wrong, and there was brand damage because a lot of people trust The Guardian. Over the years they built this level of trust up. I don't think The Guardian necessarily took brand damage on that one by saying it, but I think WhatsApp did. A lot of people went, oh, I mean, including went, oh yeah, The Guardian's done this research, and usually The Guardian's quite good at doing the bastion of freedom of speech and freedom of expression. They're usually quite good at monitoring these sort of things. So they got it wrong there. So brand damage in that case happened. And the last one is user experience compromise. And this is a big one. User experience compromise is something that really stops people using an app. So basically, you might turn around and say, okay, I've got some users, they're playing a game, and they've hacked the game, and they've just bought powerful items. And they're now playing it. It's not affecting anyone else. They've hacked the game, so what? I'm not going to worry about it. But if those people are taking over the leaderboards, if the leaderboards are now all maxed out, and an average player like myself who isn't hacking their phone can't then legitimately beat their scores, then I'll stop playing. Or if I'm playing a versus game and they just come along and one-shot me because they've got a hacked app with an I win button or something like that, then I'll stop playing. So if the user experience is compromised. Also, someone's found a way of dotting the server, and I've know people have said to me, why would anyone do that kind of thing? And the answer for that is, for the lols, people will just take down a server because they can. There doesn't have to be a good reason for it. People are sometimes just complete asshats. I should know. I'm accused of being one a lot of the time, but yeah, I think when you start looking at how are your legitimate users' experience compromised by an attack of any kind of nature, you've got to take into account. So especially if you've got games, and a lot of this piracy to do with games, but if you've got games and people are committing piracy or committing fraud inside the game to get items they shouldn't have, does that impact another player's fun? If you look at things like World of Warcraft, with the market, that is severely affected by botnets or money farmers. Things like EVE are severely affected if a normal player can't afford items on the market because the average price of things is higher because people are bot farming, then that is a real exploit. If I come along to mine and there's no asteroids there because someone's botted them all, that's a real problem. So you've got to think about that when it comes to mobile security. So we want to write things, and I don't like calling people programmers. I like to think of them as engineers because you want to be bigger than just a code monkey. So the mission of a mobile engineer who is a security-minded engineer is this. First of all, everyone has to be aware of designing security in for day one. You shouldn't be coming along at the end of your project and adding security on. You need to be thinking at the day one, where's the security going to fit? That doesn't mean you necessarily write it. When you're writing a pilot or prototype, you might be sitting there going, I've got an auth header here, I'm going to change my auth header later. As long as it's done before launch, That's all that matters. But you have to have that design. You don't want to be coming back saying, I need to change my login process, or I need to change my password reset, or my phone number validation is wrong. I've got to go change a whole bunch of code. Get that validation in, the design in from day one. The second real challenge for the developer is not to be a bottleneck. This is a word I use a lot at work, because it's our biggest challenge is not to be a bottleneck. It's a team project. So if you're the security geek in the team, if you're the security champion, you can't be sitting there going, we've got to hold up work for 2 weeks while we add security. Which means using the right security solutions at the right time to minimize the impact on feature development. Because if you stop a project because of security concerns, that's a bad thing. Now, sometimes it's the right thing, but it's a bad thing to happen. So you need to make sure that as a security engineer, you are helping progress feature development in a secure manner. And this ties on with the fourth point, the next 2 points, which is you, as a security engineer, you've got to work really hard to help achieve features. You can't just turn around and say, no, we're not doing that. You have to help the person or the product manager or the other coders or the testers understand what the problem is. And I am getting updates to my computer, so kill those. You have to make the person understand what the problem is, but then you have to actually help them work around to a solution. So I had a problem with one of the things the guys were trying to do in one of the projects we had, which was they wanted the sign up to happen in a particular way, and it's like you can't do that because I can now break it in the following ways. And we changed, or actually we had a method where it would basically allow me as an attacker to work out whether a random person was a user of the service or not. I could basically just game the system and get data out of the system. And what we did was we just worked through the flows, and we worked through and we changed the order. All happened was we changed the order of the screens. And by changing the order of the screens, we still had that feature. We still had an upload your phone book, but it was a secure feature now. Now as a user, you knew that your data would be safe. Someone else couldn't work out who your friends were or who your contacts were on the address book. As a social app, that was really important. But the matter was how you handle that. It's very easy to be a security geek and just say no. It's much harder to be a security geek and say, okay, well, how do we get there? How do we work around this? Push the boundaries a little bit. And that's the difficult bit. That's the real challenge, is to push the boundaries whilst achieving a goal. The last one is make security a feature. Let's not hide the security away. And I think this happens a lot. People, especially people who will add features in and they're hidden away and they're not talked about enough. We do amazing work. We do amazing work adding in a lot of security. Well, let's make those as selling points. Those are value-added services to our customers. Let's say you build a social media app and it's got a chat in it, for whatever it is. Let's talk about end-to-end encryption. Let's put that on the product marketing, saying if you send someone a chat message, it's safe. It's got to be safe. Let's do it. Let's make it safe. But then let's have it as a product feature. So when you go to someone's app and say, does it do this thing? It should be there. Say, yeah, your security is a concern of ours. These are the features we've added. So don't just go, oh yeah, we've done it. Sell it. Make your product managers aware that this is something that people should be looking for. These people something care about. And I think what's happening is that people are becoming more and more aware of security, especially over the last few years with a lot of very public data breaches that have happened, and more that's happening. We need to be better at putting better security in. There is what we call the trivector of security development. There's cost, usability, and security. People used to talk about the triangle of software development, which is you can have it cheap, you can have it on time, and you can have it working, and you can have two of those things. Well, I assume the thing works, okay, so let's just assume it works. Now you can have it usable or secure. You've got to find the happy medium for whatever app you're building. And that moves, that point moves. If you're building a very funky, user-friendly game, it moves differently. If you're building an enterprise business-to-business app, it moves differently if you're building a healthcare app. The level of security, the level of pain that you can put your users through all depends on basically how much you're paying your users. If they're paid employees using a business app, it's different to an end user that is paying you to use their app. So you have to bear that in mind. And you have to get the right requirements. You have to look at what the risks for your individual app are. So many years ago, I had a conversation with my friend. He's probably forgotten about this. And he basically, I paraphrase a little bit here. Now, Ben works for Mozilla, and we were talking about mobile security. And we were talking about he was building apps and he said that he didn't. We were having a problem. I wanted to download something from the server and execute it. And he said, you can't do that because I just don't trust the server. As a mobile developer, it's very easy to go, the code I have locally is safe and secure. The thing I'm talking to, that could have been hacked. I don't know if it's the real server. I could be in a cyber cafe, someone could do a man-in-the-middle attack. They've got loads of things could happen. I don't trust the server. I'm sitting there going, as a server dev, this thing that's talking to me, I don't know that's a mobile phone. I don't know what that is. That could be a postman. That could be a bot trying to pretend to be a mobile phone. It could be anything. But my server, at least I know my server's safe. And there is basically the same argument, and it's a really convincing argument, and we're going to come on to that a little bit about when we talk about the OWASP threats, that basically it's very easy to become very polarised. If you talk about server dev, server security, you do worry about what's talking to you. When you talk about mobile, you kind of assume that your code's working fine, and I think that's one of the challenges I'm trying to overcome here, so actually you can't assume the server you're talking to is safe. That's perfect valid, but also you can't assume your own code is safe anymore, unless you start applying some of the protections. And I think you have to go a little bit further. So there's an organisation called OWASP. Pretty much every PCI training, every security training says, go look at OWASP. And I think OWASP are doing this fantastic job on basically what seems to be no budget whatsoever to explain what the threats are. And I looked at the OWASP threats for they only released every couple of years. I think they released the server ones and they released the mobile ones a couple of years out, almost like Winter Olympics, Summer Olympics. They're sort of released out of sync from each other. And I basically looked at the OWASP threats and I decided to categorise these OWASP threats. So before I tell you what the OWASP threats are, I want to show you how I categorise them. And I looked at them and went, okay, well, you'd have thought that for the mobile list of OWASP threats, they're all mobile related. But actually 40% of the threats were server issues. And this assumes now that your mobile app talks to a server. It truly is like a mobile calculator or anything else, maybe a photographing camera app. Most camera apps now talk to a server. They push to Instagram, they push to wherever. So 40% of the threats listed, 4 out of 10, were server issues, i.e. app communicating with server or app communicating with other apps, usually via the server. 60% of them were mobile apps, true mobile apps. That was actually better than it was on the previous time I went through it, where I think the 2012 or the 2010 version of this was something like, it was more like 50-50. Because I couldn't quite decide. So, very quickly, the top 10 threats as according to OWASP. So these are, I think OWASP don't tell you that there are 1, 2, 3, 4. They say these are just the top 10. I'm also very wary of any top 10 lists, because you go to like BuzzFeed, it goes, the top 10 ways to get a best night's sleep. And you think, are there only 10? Are there actually only 8 good ways and you just padded the list to 10? Or what happened to the 11th one? Was the 11th one, I just don't care, it got to 10. So be very wary of top 10 lists, because there are other threats, but basically these are them. Okay. Weak server-side controls, i.e. what's controlling your access authentication, what's controlling your logons. It is the number one problem, where I can steal a session ID from another user, or I can impersonate another app. Either at part of registration or later. So weak server-side controls are essential to get right, and that's a server problem. You can't just go into the app and fix it in the app, you have to fix it in both. It has to be designed in as a system. You need to think as an engineer rather than just a mobile coder. You have to work with either become an architect or work with your architect to say, how do we solve this as a team problem? Insecure data storage. I see a lot of apps, they just write to the file system. They just slap it in the /SD card. This is actually getting better. What you begin to see is Android and iOS now have much better abilities to create temporary files which are bound to the individual application in question. So if you're using those functions, and we'll come back to use the iOS functions wherever possible, if you're using those functions, it's great. If you're using no, I'm going to make my own files, I'm going to put my own data in the files, whatever, that's bad. A good example of insecure data storage is anything which creates an image. Anything which creates an image generally will save it into the images system, like an Android, which puts it, you can make your own folders, but then it gets saved in as images, and then your Google Photos goes, oh, I found one, and backs it up to the cloud. Other application can then pick up your picture. It's really cool, because if you have some kind of like, I don't know, spirograph program, you can generate a nice image, and then you can instantly share that on Instagram, or you can share it on Facebook, because it all understands how these images work, and that's great. Apart from if you had some kind of, maybe you have a business app where it's going to save an image, it puts it into your gallery, you don't necessarily want other apps automatically picking those images out and doing stuff with them. So if you've got some kind of other apps you're looking at your images and trying to do cool stuff with images, and you've decided as a developer just to say it's the mobile gallery, that's insecure data storage. As I say, it's getting better. People are beginning to realise that the newer APIs have, and I say the newer APIs, some of these APIs which let you do temporary file stores bound to an individual application go back, 5-7 years now. The older ones are the ones, just the basic file stores, are the ones you don't want to be using. Insufficient transport layer protection is very simple, i.e. people are still using HTTP to talk to servers. Stop doing that. Use HTTPS. Use HTTP2 if you can. If you think it's difficult to set up HTTP servers, use something like Cloudflare. If you are still stuck about what HTTPS is and TLS, it's used to be called SSL, it's now called TLS. As engineers, we need to call it by its proper name, which is TLS. But basically, yes, you should be using good, secure TLS endpoints, and something like Cloudflare can help you with that. It is required, and we'll talk more specific about TLS later as something that a developer can do to fix this, to go beyond the bare minimum, which is just use TLS, but we can do one better. Poor authorization authentication ties in a little bit with the weak server-side control size and how are you authorizing, identifying your users. Now, there's a bit of difference between authentication and authorization. Authorization is basically saying once you've authenticated a user, i.e. you know that it's me talking to the server. Authorization is saying, yes, James is an admin and therefore allowed to do a function, or is a team lead, therefore allowed to kick a member. Again, this can sometimes be a mobile problem, sometimes it's a server problem. I often find this is both, i.e. you find that the servers assume the client has done some checking and therefore hasn't bothered. And you can probably hear that. For those of you who haven't seen my vlogs before, I'm actually in a shed. And there's a road about 20 metres away where there's an ambulance station, so we get silence. I'm very sorry about that. But it's a beautiful shed. So I do all my work. Secure shed. Broken cryptography. Okay, I had this row about cryptography so much. So many people don't understand the very basics of cryptography. When you start doing a lot of mobile security, learn about the basics of cryptography. The basics mean understand how symmetric cryptography works, i.e. AES. And then understand how asymmetric cryptography works at a practical level. I don't mean understand how RSA works with the powers and Chinese remainder theorem. Don't worry about that. Understand what a public key is and a private key is. Understand how you use symmetric and asymmetric together. And once you understand that, use the standard functions that an OS provides or crypto library provides. Whatever you do, and I think I've got this later slide, don't roll your own crypto. I've seen people on multiple occasions do things like they've implemented AES on a mobile phone, they've implemented AES on a server, usually in different languages, or Java or in another language on the server like PHP. And then they said, when I encrypt it, I can decrypt it on the server, but if I send it to another server, it doesn't decrypt. And you sit there looking at the other server or whatever they're being said, this one that's got the problem. You sit there going, well, it's using their library, it's using AES to decrypt. And you sit there going, whatever you've done, you haven't implemented AES. You've done something weird. And because you haven't implemented it exactly right, you've probably got a security bug. So use the standard libraries. Also, try and update those libraries. So if you're using, as soon as it's depending on OpenSSL, make sure you're updating whenever the OpenSSL come out with a security fix. Always update that. Also understand that things that are secure today may not be secure tomorrow. So if you're someone who's sitting around going, I put all my passwords in MD5, that's a secure hash, right? It was. I'm very sorry, MD5 is no longer a secure hash, hasn't been for several years. So you sit there going, oh, I'll upgrade to a SHA-1. No, SHA-1's also now not recommended. I'm using my language carefully. You should be using SHA-256 or whatever. And 5 years' time, you're going to look at this video and go, you said use that. You should be using SHA, whatever. You've got to update your libraries, you've got to update those type crypto. I know I just put hashing in the same sentence as crypto, so if people are crypto nerds, and by the way, people are crypto nerds watching this video, I'm amazed because like this is below that level. But also, if you're not a crypto nerd and you want to piss off crypto nerds, just put hashing into the same. So, I do crypto all the time. Yeah, you SHA stuff. SHAing isn't quite cryptography, but a lot of the time you can use crypto to produce secure hashes of things, and it can really piss off crypto nerds. So, if you learn nothing today, is how to piss off crypto nerds. Client-side injection. Loads of people know about SQL injection on servers, things like that. People aren't so aware of client-side injection. And client-side injection happens a few ways. which is basically I can cause your app to do stuff. There's a really cool bug in iPhones, I think it was, where I could send you a message which would crash your chat, your standard iMessenger. And it was by combining some Unicode characters together that the client would then try and render and break horrendously. I think it was like a rainbow coloured flag or something like that. I don't think they'll make any political statements about that. I think it was literally just a bug in how that control code was constructed. So when you look at client-side injection, it's I can inject stuff into your app, maybe via another app, another API, which then gets delivered to the client, which then may break or degrade or hack the person. So can I send an email to the person with a link in that launches the app? Can I put an intent from another app into your app? Can I send you a message through the system which has Unicode characters in or has a buffer injection or something like that, which then breaks your app and then exposes functionality that then allows me to do something else? So client-side injection is something that people aren't necessarily aware of. It's basically a bit like saying cross-site scripting. Are there potential threats that people could do against your apps? And people find these things. It's been found in so many social media apps about client-side injection. So, and generally they get fixed quite quickly, but you find them. Security decision via interested inputs, pretty again, pretty standard thing. Often what you should be saying is security decisions, if it's a service, should be handled by the server, and therefore you need to send anything coming up from the mobile device, you've got to basically treat as untrusted input. So you've basically got to go around that loop again. Improper session handling, I think, is a weak server-side control again. How is your session handling on the phone? Are you storing your session identifiers in the correct way? So on. And lack of binary protections, and this is the one which people don't. This is the one people know the least about. That when you have an app, it's on someone's phone and it's safe, right? And you go, yes. They go, well, yeah, mostly the OS does a rather good job at preventing other apps from invading its space. Generally speaking, unless they've got a rooted phone, in which case you put rootkit protection on and things like that. But when you've got that app on the phone, especially if it's an Android Java app, then you can begin to use Java to inspect the app itself and sort of attack the app. So binary protections is, how do I know that someone hasn't modified the app and redistributed it, so that the user is no longer using the legitimate app, they're using a fake app on the App Store, and the App Stores aren't always fantastic at removing fake apps. So it's something to be aware of. We will talk about binary protections later, but it's also about making sure that if I fetch the app from the App Store, I start taking that app apart, I can't then use the app as a method of attacking your servers. So I can find out your server endpoints, I can find your server URLs, any keys you've embedded in the app I can rip out and start using again to attack the server. So I can start using that app as a fake app to attack the server, or I can re-release the app with my own man-in-the-middle attack, my own server IDs in, so people log on to my fake app and then log out. You see it all the time, people releasing banking apps which are not by a bank, they're by someone else, and they're hoping that someone downloads the app, does a search for the bank, downloads the app, installs it, and then magically becomes it starts gathering information about the user. So you've got to be really careful about these binary protections, about how your app may get misused by people in the world. And we'll talk a bit about binary protections. Well, some of the real clever stuff about binary protections comes later on, but it is worth knowing about. Okay. I thought I threw the slide in. I did debate about taking this slide out or not. So, how do you classify threats? Let's say you've got an app, you've got an idea, you've got a system. We at Proxama use this method. We were showing it by ARM. For those of you who don't know, I collect mugs from the customers that I've worked with. So ARM, I have my ARM mug. Props, you see. I've still got a couple of companies I'm trying to get mugs from, and every time I go there, they serve us in like normal little white coffee cups, and I want like a logoed mug from those companies. So I have got a short list. Okay, so the company in question, ARM, searched this. They basically said we categorize attacks in 3 levels. So a hack attack is basically, can I convince you to click a link? If I can send you an email, the link in, can I send you a message? Can I remotely cause you to do something? And basically it's attacking other people's handsets through some kind of remote thing. Shack attacks are more interesting. Shack attacks are basically, you've got physical access to the device and you're doing something to it. And the rule basically is that £1,000 of equipment is the limit. So it's what people have got in their own home. Now, people go, why would you take your own phone apart? Why would you do that to your own phone? And so, well, actually, people were doing that to Xboxes. The original Xbox came out, and people were taking them apart and soldering a little daughter board onto it, which let them play hacked games. And people were doing that. People will willingly do that. So if you went to someone and said, yeah, if you do this to your phone, you'll get free Oyster travel for life, people would do it. So you've got to worry about shack attacks a little bit. Shack attacks are basically suggesting you can data probe and get stuff out of the bus. So if you're communicating between devices, can I data probe and get something out? The reason you worry about that is people do that. People have dev boards. People like me have access to this equipment. If you've got some application which you say is secure, and we discover in a shack attack that it's not secure, or you've broadcast your keys or something like that, then that gets published. And if that then exposes a hack attack, you've got a problem. And that's where lab attacks come in. Lab attacks is when you start taking chips apart. So lab attacks are the step higher. Lab attacks basically means you need access to electron microscopes. You need very, very detailed information. And again, you sit there going, lab attacks don't work against my device. So the kind of things we work in banking with cards is that lab attacks don't work. So if a lab attack doesn't work, it means a shack attack won't work. It means you don't have something which becomes a scalable attack. Now, there was a case with MyFair, a very embarrassing case where they had a chip. It was a NFC chip, which the Oyster card was based on at the time. They've moved over to something else now called Desfire, but at the time it was a MyFair card. And there's a bit of cryptography in it, which allowed you to unlock and write to the card or not. And it was a secret key, and it was supposed to be a secure chip. It was supposed to be unbreakable. And they were a bit cagey about how it worked and a bit cagey about the crypto for a long time. And then a university basically took them apart. And they went, the random number generator on this chip isn't very random. They looked at the design and basically said, we think we can hack this. And it went in a matter of weeks from a lab attack, where you had to be slicing these chips open very slowly one by one, to a hack attack in that any mobile phone with an NFC adapter in could hold against one of these tags for about 30 seconds, and you could work out what the keys were for the tag. So by exposing a vulnerability which they knew about and they designed in to cut cost corners, there was a hack attack on the back of it. So you've got to worry about these a little bit, going, are you aware where the data is? Are you aware of the system design? Is it potential that someone could get this information back? And you can do the risk calculation. It's not a reason not to do it, but it is a reason to understand. So when some of the things we're going to talk about much later on combat shack attacks, they don't necessarily combat lab attacks, they do combat shack attacks, and they combat lab attacks a little bit. Hack attack. One of the things about SIM cards definitely combats lab attacks, but generally we're trying to stop hack attacks, and we do it by stopping shack attacks at the same time. Now, it's not doom and gloom. Let's get this clear. First of all, mobile security is getting a lot better if you keep up to date with good programming principles, and that's one of the big challenges. Is to talk about Nordevcon at the beginning. Is how do you convince your bosses to let you spend a bit more time doing a better job? Okay. And the first thing is that OS functionality is getting a lot better. So we're beginning to see keystores in phones. We're beginning to see hardware-backed keystores in phones. And I got asked what hardware-backed. I purposely haven't mentioned hardware-backed yet, because I will talk about hardware-backed stuff a bit later on. So first of all, there are beginning to things like access to fingerprint readers, access to strong authentication. Those functionalities are really becoming along. The OS vendors, Google, iOS, talk about this a lot more. It's a lot easier to access their functionality. The APIs are becoming easier to read and understand. And also, you don't necessarily work with the primitives anymore. They're beginning to give you access to functionality in other areas which use those primitives. So they have secure storage. They use things like application level access controls on data storage, things like that. It is getting better. The first thing is use the OS functionality where you can, and then bring in a rootkit detection if you can to make sure that you are using a legitimate operating system. Because the moment that if you're basing your security around the OS providing that security, and then it turns out that the OS actually is not providing your security because it's not the OS you think it is, that goes a bit wrong. So rootkit detection. Now rootkit detection doesn't always work. It's a bit of a race condition between people writing rootkits and people writing the rootkit detection. However, I'd bring it in. I'd still bring it in, try and use it. And discourage your friends and family from using rootkit phone. You sit there going, but I should have the freedom to choose my operating system. You do have the freedom to choose the operating system. Let's choose a secure one. Or let's use that new Nokia coming out, which has no operating system on. It's just Nice phone. Wow, that's not nice. The last point here is quite interesting, that all is not equal. I love the Samsung phones because I happen to know on Android, the Samsung phones, the Samsung Nordevcon, have light years of security ahead of other mobile Android operators. So one thing here is SE Linux. They added SE Linux on Samsung phone years before they add it in, about a year and a half before they had it in the Android OS as mandatory. And then it got a bit interesting because when they brought it into Android as mandatory, it had to have a SE Linux is a way that basically says if you want to access kernel functions, you have to have a signed app. Right, that's good. And then it has a list for each function or each group of functions, which group you're in, which your signatures are allowed in and which aren't. And because we at Proxarm were doing some secure programming using TrustZone and using some trusted execution environment stuff, we had to be added to Samsung's list for that function, and it took quite a lot of effort to be added to that list. It was very early days of Knox. And then you turn around on other devices, and they had the same Knox TE functionality in the chip, but actually the SE, and even though they had SE Linux on it, there was no whitelisting for those functions. Any app could access it. And he started going, okay, so you have SE Linux, but you haven't actually got the same rigorous control on who can access those functions and who can't. So it's all like saying that, look, I have SE Linux. You go, okay, well, what's your policies in that? And as a developer, you don't know. You can't sit there going, for all these phones and all these different versions of Samsung's, for all these ones, what are the policy definitions that the OS vendor has put in place? And also over time, how are they changing, how new people get adding to various policies. So it's worth being aware of that, that it's an evolution, and it's evolution in a forward progressive way. I did also notice recently though that the doing some research on this again, that the requirements for Android, because Google actually have a minimum requirements. You can take the code base for Android and you can build a phone and you can put that code base on it, but you can't call it Android unless you meet those minimum requirements. And the minimum requirements now for SE Linux is you actually have correct policy enforcement. And I think for TE you have to actually have a whitelist situation there of policies. So I would question whether my knowledge of that was still accurate because of that knowledge now, saying that SE Linux has now got a lot better. But any new security feature, when it rolls out, you basically got to say, have all the vendors and all the different versions of Android for different devices got the same feature on, are things like fingerprint detection on every device as good as when a thing says, yes, I fingerprint authenticated the user, they are logged in. Does that mean the same quality authentication has happened on every device? You just don't know. So you could put yourself in a little box that only goes for iPhone, because iPhone has a much smaller number of devices, they have a much smaller number of hardware, so therefore your quality standard is much more similar to each other. Or you can be nice to users and support Android and iOS. Notice I don't talk about BlackBerry, I don't talk about Windows Phone, because I don't really have much experience with the new Windows Phone, and I did do quite a lot of work on BlackBerry 10 and BlackBerry 7, but no one cares about that anymore. But did an awful lot of work on BlackBerry 10. I really liked BlackBerry 10 when it came out. Became a real BlackBerry fanboy for the first time of BlackBerry 10. But our customers basically stopped asking for those things. That's why my knowledge there dropped off. So instead of talking about Windows security, I'll be going to talk about Android security more than other ones, because that's where I do most of my work. So I'm sorry if you got this far into the presentation and realised I'm not going to talk about your favourite operating system. I'm really sorry. Okay, so again, back onto beautiful slides, and we haven't talked about code yet, because we haven't gotten to how to deal with the main things. So good practice: don't implement crypto primitives, don't homebrew, use well documented open source libraries if you can. If you've gone a step further than that, you could even buy Whitebox crypto libraries, although you could use Whitebox and have crypto libraries built into your applications, even better. But use ones which are peer reviewed. Okay, use ones based on OpenSSL, use ones based on whatever. As a example for this, in Python, we do a lot of Python work, we do a lot of crypto in Python. We have just moved our crypto library, the base library we're using, because the old one was basically developed by one guy. He hasn't done any patches for a year and a half. The support there has dropped off. And there's another library came out which started as a fork of that, and we now it has a much better maintenance record, it has a much better bug fix record, it's tying the security flaws that people have found with it. So we have swapped our library because we're not happy with the library supplier that we had originally. The second one is use the operating system. I've said that several times. Use the operating system function. If you've got things like file storage, secure file storage, use the OS functions to do those things. Don't write your own unless you really know what you're doing. Also, really simple stuff. Understand crypto I've talked about, but don't store stuff you don't need. A number of times I work with developers, work with product managers. Oh yeah, we'll just stuff all that in a local database. We might need it later. Go, if you might or you do. If you do need it later, we've got a good business reason to store it. Store it. If you don't store it. So let's not store information on the handset that we don't need. Does the handset need to remember your birth date? You know, if you want to do something cool where you give the person a birthday present in your app, or say, hey, happy birthday in your app because you remember their birthday, you collect it on day one. Keep it on the server in a secure manner and send them a push notification on the day. Don't store it in the app where it might get nicked. Similarly, cache control, wipe your caches. Use data flow diagrams to make sure that you've got the right data and not storing extra data. There's techniques out there you can use in your planning, in your architecture to make sure you're doing the right job. Also logs. Don't log blindly. Don't just log data randomly. Google themselves on developing Google Pay, the precursor to Android Pay. When you typed your PIN in, it printed your PIN to your log. Which is kind of bad. It's not the end of the world because it's the kind of hack where you kind of go, oh, to exploit this you have to actually plug a cable in and then you have to type your PIN in, and then the output of this is you see what the PIN is. The point was that if it's printed in the log, there are other log aggregator programs which might get access to the logs, and therefore it was a bad thing to do. It's all right to print off a PIN was entered and validated. It was wrong to say PIN 1234 was entered, because everyone's PIN obviously is 1234. So if Google can get it wrong, we can get it wrong. You can't be perfect, you just have to get better, that's all. Okay, so let's move on to part 2 of this, which is actually talk about what you can do about fixing some of these issues. The first question is about authenticating the user. When you have a user, the first question you need to ask yourself, are you authenticating or identifying the user? And this one has been interesting. When you have a lot of apps, is do you actually even care who the user is? Or do you just want to make sure that the second time you see the person, it's the same person you saw before? I.e. someone can't steal a user ID. So a lot of apps, I'd say it's latter. You don't actually care who the user is, you just care the same person every time. So every time the app connects to your server, it's the same person, it's the same app. And it matters, because I'd say, not in my case, you require strong re-authentication. Now, I did say in my experience, obviously I work with banking, a strong primary authentication, i.e. knowing that it's person X. One of the things I say about what I do is we put credit cards into phones, put debit cards into phones. It's really, really easy to put a debit card or a credit card into a phone. Really easy. It's really hard to put your credit card into your phone. That's the clever bit. So we spent a lot of time and effort doing that. Actually, putting a card in your phone, we got that 10 years ago. You know, that's easy. But the technology to identify you, and then when you are going through that process of signing and logging, securing that identity session, either authentication session, that's where the real knowledge is. That's where the real experience is. So re-identifying the same person every time that bit of information comes up to a server saying, yes, it's from the same device, from the same app on the same device. Really important. You've also now got some interesting OS features here. So first of all, you've got something called the Android Advertising ID and the iOS Advertising ID. These are quite useful features because they help bind you apps together. Now, they can be reset and they can be manipulated. You've also got things like your FCM Push ID, which can be reset, but you're in control of when that's reset. So don't try reinventing the wheel using phone numbers. There's loads of problems with you. People say, oh, I'll track your phone number. Pay-as-you-go phone numbers, if you don't see it for 6 months, you're supposed to delete it because it could be reassigned to another user. So phone numbers can be problematic. They can move between people. So an interesting one is lock screens. Again, from the banking world, everyone says, oh, we must put a lock screen in the app. Google's advice on this is don't. Use the OS lock screen. You can actually in your app, especially as a business app, say your app must require a minimum level of security, i.e. must require a PIN or a fingerprint or a swipe before you can use the app. So the person puts a swipe in. At that point, the data is bound to that crypto by the OS. So if the user then goes and turns off their fingerprint or turns off their paying code, maybe they've smashed the screen, they've taken it into a repair shop, and the repair shop say, okay, you need to take your pin entry off so we can test the phone works after we've done the repair. So they take the pin off. Taking the pin off will wipe the data store, will wipe the key store, it will wipe the information that is bound to those OS features. So you don't necessarily need to. At that point, you just go, oh, okay, I'm very sorry, your key store is wiped. Just log in again, start again from scratch, and by the way, re-add in your, put a pin back on your Android lock screen, and done. So use these functions. Use strong server communication, use OAuth, use things like that to actually communicate strongly to the server, but use things like the Keystore. We'll talk about the Keystore a little bit more maybe later. But where? Next slide, in fact, use the OS Keystores. Obviously, I read through my slide deck before this. So Android has this thing called the Keystore. Now, sometimes this is hardware backed, and I'll talk about hardware backed probably now. But Keystores, basically, it's a bit weird, it's beautiful, but at the same time it's really annoyingly bad. So the Keystore can store public-private keys, RSA keys or EC2 keys. It can't store symmetric keys, which is really annoying. So basically what you when you use the Keystore is you actually use the OS functionality to create or store a key, and then you can get it back later inside your app, but no other app can get it back as long as you don't turn on the flags which allow other apps to get back. I think you can turn it on so other apps by the same vendor, i.e. if you have two apps with the same signing key, they can both access the same key, which is very useful if you've made like companion apps and that. So the key object you get back, when you actually use a key from the Keystore, you don't actually get the key back. It doesn't come back in plain text, it comes back as a handle. So when you start using crypto, you say, oh, now encrypt this data with that key. You never actually see the key. It never comes into your memory. It actually stays inside the Keystore. When you have a hardware-backed Keystore, it actually means that is never in the physical memory of the real-world device. Usually it's using something like trusted execution environment, and using like a hypervisor OS means that your data actually gets transferred to this other area of memory where you can't see it anymore. It gets encrypted and the result returned. So that the key is never in memory. It's never in memory, which is addressable by the real world. So the real world, I don't mean the user space kernel, I mean the operating system itself. Which means if I do something scary on your phone, I can't get it back. Or it's using kind of whiteboxing technology where, even if it's not hardback, it's doing a whiteboxing technology where it's storing it in such a way that if I were to do something crazy against your phone, such as cold boot it, which is, because I've just done my PCI training, I'm hot on this right now, I say hot on it, what you do is you freeze the processor with a blast of frozen air, switch it off and then boot it again very quickly, and the RAM hasn't lost its memory, so you can search the memory and look for keys or the sensitive information. And in this case it won't find it because it will be abstracted and obfuscated. So hardware backed is basically using a hardware technology to do that. Software backed on whiteboxing is when you use some other technology to do that, and we'll talk about whiteboxing later. And I realise this is going on a bit. I think you see why I'm now recording it, and imagine all this crammed into 40 minutes. So unless you go to the Super Pro mode, which we'll talk about later, use the OS Keystore. It's easy, it's trivial, use it. If you learn one thing in this thing, it's how to annoy crypto nerds and the OS Keystore. So again, root detection, so you make sure you actually are using the Keystore and then use the Keystore. It does a better job than you can do. So the kind of use you would do is maybe you create a public-private key, you sent the public key to a server, so you've kept the private key on the phone, and now you can send stuff up to the server. And what you probably do is you probably create like a one-time AES key, and then you encrypt your data with that, and then you encrypt the AES key with your RSA key, and you send that encrypted key and the payload to the server as part of a web request, which of course will be HTTPS. And at that point, the server who has already had your public key from before can decrypt it. And that means every time you send it to the server, if the server's able to decrypt it, it knows it was you or that individual app, because only that app has access to that private key in a really secure way. Much better than you saving that private key onto the local file system. I could go on about OS Keystores and its power for another half hour. Use it, it's powerful, read into it. I'll put URL in there because it's the most useful thing. I didn't want to show code because I wanted it to be management. So again, if you're a manager and your people, you ask your devs, are you using the OS Keystore? How are you storing the keys that you use to talk to the servers in? And if they say what keys, then you know you've got a slightly bigger problem. And this gets a bit more interesting. Okay, next one, certificate pinning. This is a nice fun one, and this is actually trivial. And I want to talk about some feedback I actually got back, which I kind of knew about, but I didn't expect anyone to find. Okay, so certificate pinning is basically, there's something I haven't presented, which is client certs, which is basically client certs, or when you're using TLS, not a lot of people know about them. More people know about them now than they did maybe 10, 7, 8 years ago. But client certs are basically a server cert. When you connect to TLS, it goes, yes, here's the cert server. A client cert is one you send up to say, here's the cert of the client connecting, and the server can basically mutually validate this. Certificate pinning, the way it works without certificate pinning is you talk to the server, and the server says, I definitely am a legitimate server, and it gives you a certificate which has been signed by someone else. Generally, don't worry about self-signed. It's generally signed by someone else. And that someone else is generally a big faceless corporation who's done some kind of validation to make sure you own the domain name. Now, I'm assuming your server hasn't got hacked, you haven't lost your private key on the server, but if you have, there's got a whole bunch of other problems. If you basically, it's possible to. There are something on your phone like 100 root keys, and any of those people could sign a cert to be your server. And what you've got to worry about is all those companies who can do certificate signing, do they all have good, strong processes around identifying who you are? Has someone been able to make a certificate from scratch and then ask one of those companies to sign it and convince them via some social engineering attack to say yes? Certificate pinning solves this. Certificate pinning basically says, I'll put a server on my server, I'll probably get it signed because, it's good. But what I'm going to do is I'm actually going to keep a copy of that cert on my phone. I'm going to compile it into the app. So every time the app dials in, it's going to check that the cert being used is the cert I thought I gave the server. And then it's impossible for someone to do a man-in-the-middle attack. It's impossible for someone to install onto your phone into the root certificates an extra certificate, because that's happened. Usually, actually, Android's getting better at telling you it's happened, but it happens. So now you've got a certificate on the server which you can actually yourself know is the right certificate. Forget about the CA at this point, it's you being pinned that certificate. Now if you do this, you have to think it through. Think through what you're going to do when you do rotate your server certificates. You might want to have an array of valid certificates. You want to allow sharding so you can actually begin to do a rolling, it'll work for 6 months, I change one on the server, but I'm going to add old ones in and stuff like that. The other thing to think about is having a version up test API. So I like version API, so the app can dial and say, what's the current version? Do I have a mandatory server upgrade or not? And make sure that that API works with HTTP, so you can do, so in case the certificate's broken, someone doesn't use the app for the year, starts it up, go, yes, I have to upgrade before any functionality works. So you might just think through how the app manages version control inside of itself so it can work with the servers. But certificate pinning, a little bit harder than the Keystore stuff, which is quite trivial, but actually it's not that hard. Now, I did this presentation, one of the chaps who was there has gone away and implemented it, and he came back and said, yeah, all our users in Saudi Arabia now have a problem. And I think they would do, because I think Saudi Arabia do man-in-the-middle attacks. They replace the server certs with their own certs. They can look at internet traffic. And by doing certificate pinning, it stops them. It stops the app talking to the server. So it doesn't stop them trying. It doesn't magically make it work. It doesn't magically say, I bypass that security. What it does, it goes, the server I'm talking to right now is not the server I thought it was. So going right back to the start of that conversation that we had, where I showed Ben's comment saying, how do I know the server is the right server? Certificate pinning is one way. Now, it doesn't let you know that someone hasn't nicked the key from the server and put it on a different server. Disgruntled employee, a bad sysadmin has just left it public. Heartbleed, publishing it. Those things can still happen. But this stops a man-in-the-middle attack where a organisation has got a root key on the phone. It tells the app the server is not the original server. So someone trying to now break into this now has to hack those apps on the phone. So this is not that hard. It's a little bit more tricky. We're not on the enterprise stuff yet. We're not on the difficult stuff yet. This is well within the reach of an average programmer. to do. You actually don't even need any server mods to do it either. As long as your server's doing HTTPS, you can download your HTTPS certificate from the server and pin it. You can say that's the certificate fingerprint I want to make sure is there. You can do this. However, don't just do that. Make sure that your product manager, make sure that your organisation knows it's happening, because you have to plan about certificate rotation. Otherwise, your SysOps guy goes, "Oh, it's the 5th of April. We're rotating all our certificates on." It's the 6th of April. That's almost right. We're taking all our certificates on the financial year for some reason, and all your apps just stop working because you haven't got the new app out now with the certificate pinned in. Also, don't let your certificates be downloadable. They have to actually be compiled in, because you want to do the buying protection on the certificates to make sure one hasn't just managed to insert a valid certificate in. So you have to make sure you do it right, but it's very trivial to compile the certificate in. You just put it as a data file that gets compiled in. And then with buying protections for that, it's good. So, certificate pinning. Do it. Unless you're in Saudi Arabia, in which case do something else, which is double encrypt. Use a Keystore to encrypt your message and still do HTTPS, but allow your certificates, have an array of allowed pin certificates. So if it matches those ones, say yes, I allow the government to listen to my doubly encrypted data. Make sure also that you always abide by your local legislation of country borders, and don't do stuff which is illegal in a country of your target because you don't want to get into trouble. I probably have to say that, otherwise I could get into trouble with like IET or something by giving out bad advice. So make sure you do that. The ones to watch out for, I think, are America, France and Korea North, where they have rules on the level of encryption that can go across the border but not necessarily internally. So in that case, for various other reasons, if I was running an American service, I would probably run servers in America. I use AWS, so it's really easy. I'd run servers in America containing America data, and I'd run services in the EU containing EU data, and I would run services probably in Singapore or something like that because of AWS locations for everyone else. That's very almost racist of me to say, but it's because I don't actually have many customers over there, so I can just offshore them. Do I UAE data center? UAE data center? Not sure AWS has that, but the reason being is that EU has data protection in the EU. We're currently not exited the EU, so it's okay for me to host in Ireland. There is now the London data center. But I can host in the EU and know that I can transfer information between places and not get into trouble. America, I would keep the American data separate because I don't want them saying that their American data is on my EU server and therefore get warrants and access to that information. It allows me to contain my data nicely. That's what I would do. It does require more SysOps work, so you've got to be careful about how you do that. Bit of a side one there. Okay, right. These are also more easy things to do. So we're now on to easy things. Better service architecture. Strong auth and requests. Put our auth in. Job done. Libraries. There's libraries for this. Pick a language, there's an OAuth library for it. In fact, there's probably about 10 OAuth libraries. Find the one that works for your framework. The next one is transactional request velocity. This is quite an interesting one. You basically can do cool things where you see a device, you see it logging in fast. Let's try it. Say it's tried, 10 logins in a minute. Block the device for half an hour. Build into the system so you then back into a code saying, no, I'm sorry, I'm ignoring you for half an hour. If they try 100 logins in a minute, that's a bot. It's the bot that's not even trying to hide itself as well. So request velocity, transaction velocity. Transaction doesn't mean financial transaction. Transaction means server transaction velocity from certain IP addresses. You might turn around and go, oh, it's a public IP address of my testers, and I've got 20 testers on one Wi-Fi network. That's why I'm getting so many requests. Be aware of that. But generally speaking, you could get interesting stuff there. Last point, I've said this so many times. Demand TLS on all API calls. Get Cloudflare. Job done. Or another alternative provider. TLS. The number of apps that still don't use TLS astounds me. Facebook moved over to demanding TLS. When you use Cloudflare, it's one tick box. You tick it, say no. I forbid HTTP from now on. Facebook only moved over to TLS always surprisingly recently. Bearing in mind this is stuff that's been around for ever. Enforcing it, saying all apps must use it. Just do it. What could go wrong? Nothing. Okay, so now we're going to go into a bit more of a challenge. I've also got a suspicion I used this image earlier. When you're finding images for code as something for people to look at, so they don't have to look you in the eye when you're standing up in front of them, it's quite hard because you either show them, people using phones. Yeah, I've used those pictures, and this one really annoys me because this obviously is someone coding, and that's what the person who took the photograph thought it was, and quite obviously it's someone pinging Google's DNS. And not getting very good ping times either. It's a bit worrying. And they also seem to be writing a website, some HTML. But it annoys me. It annoys me I can't get good quality photographs to make things the size interesting. Otherwise you just have text, which is horrible. Anyway, I digress. Binary protections. Lack of. Okay, so we have an application. It is relatively trivial for any talented engineer to retrieve your application from the web store, from the phone. I can install it on my phone, put it back from the phone, and then inspect it. And automatic tools will do it for me. They will rip out the functionality. It will expose data files in there. I can just unzip it and look inside it, have a poke around, look for functionality which maybe isn't apparent, look for functions in there, and then even start using that code in my own app so I can write an app around it. So most of the time we don't need to worry. Okay, so most of the time you don't need to worry about it, but we are going to look at the 4 methods that I use at Proxama in the financial world to or have used over the years to protect this. And the basic one is code signing. So code signing is amazing. All apps should be signed so that when the app is installed, it validates that the code hasn't been manipulated from the developer or from the app store. You know it's a genuine app. Code signing is now bigger than it was. Even desktop applications are signed now, and you begin to get warnings. Some developers still don't sign their apps correctly, and I have a moan at them when they do it. Some even quite big organisations, some incredibly secure conscious organisations, they have a beautiful Windows signed app, and their Mac app is not signed, and you have to go into a menu and say allow this app from this source, and you sit there going, why haven't they just signed it? It's not that hard. So code signing. You sign the app with your key, the OS checks the app and signature, any tampering is spotted, and therefore no dodgy can be run on the phone. And I said that you should always use the OS function, so it's definitely all you need to do. You don't need to do anything else. There's no risks or problems whatsoever, right? Actually, the problem with code signing is that it's true. It does do it on install, but it doesn't do it after install. And it doesn't do it from reissued applications. So if you code sign your app and I download it, modify it, and re-sign it as my app, then the new signature is correct, as in it's correct, it's come from me. And the other problem is that it doesn't necessarily validate the app only on install. It doesn't necessarily validate the app now. So every time you run it, does it revalidate the app? With Android, when it recompiles the app as well, it's almost impossible for it to. The new Android code makes it even worse. So does the OS know the app hasn't been tampered with? If you've got really funky things where you're downloading patches inside the app or data files that then execute weirdly in VMs or kinds of things, does it validate those as well? We've seen people have apps which downloads contents both desktop, on game consoles and on phones, where the apps which are secure download code from a server, then run that code, and you can inject your code, client injection, what we talked about earlier. And that's the way into a lot of these things. Re-signing is a big problem. But that means don't do it. It means, definitely do code signing, because it means if someone has downloaded a legitimate app from the App Store, they are protected. However, it isn't the end of your worry. Okay, so what we then do is start looking at inline code examination. I'm missing another image here. I'm missing 2 images so far. My beautiful presentation ruined. So first of all, to do inline code examination now becomes a bit tricky, because it basically means you can't write in Java. Okay, so for all those Android developers who go, I write in Java, you can use Java against itself. So the first thing is you have to actually write your code in something like C or C++, and then you have to get a code tool which is going to inject code at compile time. So as you compile, you compile down to bytecode, and the bytecode is going to be injected as part of the tool chain to add little bits of code in which are going to do checksums of other bits of code, and it's going to do a lot of them. It's not going to do one checksum of the lot, it's going to do a lot of little checksums of it. So this bit of code is going to check this other bit of code, this other bit of code is going to check another bit of code. And the idea is you're layering checks upon checks upon checks. Now, there are some open source ones you can use for this, but there are commercial ones you can use, and I would recommend the commercial ones because they do a better job. So the idea is that you end up with this massive problem where if I want to modify one line of code, I now have to work out what bits checksum in that, modify that checksum, what bits checksum in that, modify that checksum. So to change one byte of code, I probably then got to change 30 or 40 checksums, which is very, very cool if there were simple checksums, but they're not. The inventors of this come up with loads of different methods of hashing or secure hashing these bits of code to make an attacker's life harder. So inline code examination is very important. Now, what actually happens is you auto-inject those codes. So you have a build tool which does a run of the app, and it auto discovers what bits of code call what bits of code, and it builds the code. So every run through the app will check every run through. Now, you have to monitor performance. When we talked to the guys, we went through some training one particular product vendor, and they were very surprised at us because they basically go in this very defensive mode, saying, yeah, the app developers they usually work with don't want to add this functionality in because it slows the app down. And they said we were the first people to actually go, how do we guarantee on every run through it has actually checked every single other part of the app? We wanted to put more checks in. That's very unusual, but it's doing good enough. But yeah, it does slow down performance because you're adding all these checks in. However, it is worth doing. So what you do is you monitor the performance of your app with the settings and the tools available. So shop around for the most effective tool for your situation. You also need to decide what to do when an intrusion has been detected, when someone has modified code, and there's some really ingenious things out there. And we're going to talk about Whiteboxes in a moment, which lets you do even cooler stuff. But basically, the first thing is you could just stop working. Okay. The next thing is you don't have to stop working straight away. You could continue, but you could add a flag into the data saying, yeah, we know this is dodgy. So the person isn't aware of where they've modded that it's gone wrong. Games have become very ingenious at this. They may do a thing where your armor value, I saw one game where I think the armor value degraded. The displayed armor value didn't, but your armor value degraded, so you could be one shot by anybody if you're using a hacked app. So you're playing the game and your armor value degraded slowly over the next 10 minutes. So it looked like it worked. It looked like the hacker had managed to successfully break the bypass or do whatever they were trying to do, but actually all they'd done was break their own game. So going back to that first thing of degrading other people's performance, you've got somebody who's playing a legitimate app just running around, yeah, I just one-shotted level 20 or level 99 or whatever, I just one-shotted them with my little slingshot or whatever. So actually you could actually build some quite cool features where people who are hacking out get a worse experience and people who aren't hacking get a better experience. But on an enterprise app or a business app, you might just go straight into shutdown mode. Now, or you might wipe the local data. You might not close the screens down so the person isn't quite sure if the app's working or not. You're not necessarily going to just display, yes, we've detected you've done that. You may just do something slightly different. But you've got to decide what to do when in different situations. So if you're building an enterprise app versus a game, there are differences there, what you might do. Look online for what some of the games do to help. It does two things. First of all, because the app continues working, the person who's hacking it doesn't realise they've made a mistake. So they don't, if they're making lots of changes, which you generally are doing, you don't know which ones have worked and which ones haven't worked because you've got to play the game for another hour or two. So it really slows down that cycle of development. It also means that people are using, the downside of it is that people who then got the pirated app, it works, but then it goes wrong, an hour into playing, and they have to restart the game every hour. And they're saying, oh, the game's really rubbish because it does this, this, and this. And then you go on the forums and people just go, yeah, you've got the pirated app. So I don't know if that's a good or a bad thing because they have a bad experience, but they shouldn't have had a pirated app. And where they are aware they had a pirated app, some of these people aren't very clever. They just downloaded an app, thought they can't just download it. Not aware they've committed the crime necessarily. So inline code examination is very big, and it ties in with something that happens a bit later because you need to have quite a lot of code in the lower level language, the C++ languages, to be able to do it. So if you're building an app with lots of UX, the UX is probably still going to be in Java or whatever, and then you're going to fire that off into your kernel. So anything talking to the server will be built in this lower level language to protect those sort of business level functionality. And I wanted to compare security levels. So this rule gets quite interesting. If I have two security products, two security solutions, let's say I have a whiteboxing technology, trusted execution environment, and a SIM card. UICC is basically SIM card in the mobile environment, SIM card. How do you work out which one's better? And so I did. I drew a graph. Here it is. And you quite see the SIM card is better than normal world. I'm very careful to use normal, not insecure. It's the normal world. I got told off by Arm for that. So, and it must be true because there's this graph. So I want other people in the future to go out saying, yes, it's obviously there's researchers researched this. They drew a graph, therefore it's true, and they can reference me because I drew the graph. So obviously it's true. It's actually impossible. It's worse than that. It all depends on what you're trying to do. So I talk about it in a moment, but the SIM card is the gold standard of security. But you can't do certain things which you can do in TE and white boxes. So TE, in some TE environments, you can take over the screen and do stuff on the screen. From the SIM card, you can't do that. You can do stuff to an app, and the app can put stuff on the screen. But if someone's monitoring the screen or doing a keys logger or something like that, that's a problem. Whereas with TE, you can do that. So you can do a lot more things in TE. However, SIM cards are anti-lab attacks. So if you can do it with the SIM card, and you have access to the SIM card, the SIM card is much higher security, but has much fewer features, like it's limited memory, and so on. So let's talk about the SIM card. The SIM card, I'm missing images. I'm missing images in the next 4 or 5 slides by the looks of it, but I'm missing images. So they use the same tech as credit cards. They're basically unhackable. They're basically impossible to clone. But first of all, you don't have access to it. Like, you can't put stuff on a SIM card. It's just the partnerships you need in place. You need to go work for a mobile network operator. You need to go access to their TSMs to be able to deploy over the air to the SIM cards. You find that inside a mobile network operator, they have lots of different kinds of SIM cards, so it's not even as trivial as that. If you're an independent vendor and you want to put something on all the UK SIM cards, so in the UK there's 4 or 5 main operators and a whole bunch of secondary ones. 4 or 5 main operators, and then say internationalization, so you've got a partnership with all of them, and that's like, okay, each one of those to get in bed with them and say, yeah, I want to do some work with you. You're looking at maybe a £20,000-30,000 per operator cost, minimum, really expensive. A second one, developers, SIM card, people writing Java card type applications are in demand. I say in demand, you can't find them. So I've done it, right, and I know enough about it not to do it. There's a guy I work with who's done it. There are some people in banking who've done it, but basically it's really specialist. So the cost of development, you use special equipment to write it. Again, testing is a pain because you've got to get all these different types of SIM cards. It's a really difficult thing. It's really, really expensive. However, 4th generation SIM cards, and I did some work with Orange. See, one at the back. We did a project with them, with their research labs, and they basically were like, we can put images on the SIM card, because the SIM card generally only has about 72k of data. So, we put images, we've got megabytes of space in these 4th generation SIM cards. It's like, yeah, they do. And you can also do something called web server on SIM, I think it's called, where you can actually put a full web server on the SIM, and therefore you can make an app which talks to APIs. Like, you can send JSON into the SIM and get JSON back. It'd be really cool. Unfortunately, 4th generation SIM cards, as far as I'm aware, cost about £20-30 a SIM, where SIM cards you get and I get are cost about 20 pence, maybe a bit more than that, maybe 50 pence. So there's no real business case to push out 4th generation SIM cards to users. In fact, I think the future of mobile phones is that they're not going to have SIM cards at all. You're going to use TE type technology. So it is the gold standard of electronic security. They're amazing. They're amazing secure. I'm very passionate about really cool secure things on SIM cards. In fact, everyone's got one is amazing. So when people talk about mobile security being dodgy, some people get very defensive going mobile security is the best in the world because they're talking about SIM cards. But in reality, for mobile app developers, it's just not a technology you get to play with very often. If you become a government enterprise, you get access to this kind of cool tech. You get things like phones which have dual SIM holders. You can put like your operator SIM and you can put your own SIM in the other one to store your keys. So this is really cool, really, really good security, but limited because you are basically limited to 8-bit Java. You are limited to these technologies. So enterprise only, and possibly not even that, possibly even only government only. That said, it does happen. It does happen. You see apps for a specific operator which works with technology on a SIM card. But for the scope of the people watching this, I think it's a tech which might be dying out a little bit and we might not have access to. Interesting enough, the difficulties around using the SIM card maybe is what drove trusted execution environment. So again, no picture. I'm very sorry about this. So ARM Intel formed something called the Trusted Processing Groups, the Trusted Computation Groups and they basically both have different solutions. The Intel solution actually uses a separate processor. The ARM solution uses something called TrustZone, where it's actually it uses the same processor, but it flips the mode. It actually saves itself out, the normal world out, and brings the rich world in. So what you generally run is you run two operating systems. You run like a hypervisor operating system, something like just Linux T-Base. But if you're BlackBerry or an iOS, they generally call that trusted operating system iOS and BlackBerry. They generally don't have a separate name for it, but there is actually a separate component, and it is separate. It's effectively physically separate. So when we talk about hardware-backed security, trusted execution allows you to guarantee this secondary security. Now, writing trusted applications actually becomes in the scope of enterprise developers, people who have quite cool stuff. There is a cost to deployment, and it is expensive. You are still looking at paying almost per deployment. The interesting business model that these organisations have is they say if you use our technology, you can basically cut down on fraud. So if you can save yourself £5 of fraud, it's worth paying £4 to install it. Whether you agree with that business model is another question, but they have a peripheral support. So some of these can then access the screen. Some of these can, on some devices, you can access the camera or the NFC stack. It's pretty hit and miss, and whether they work or not is on all devices is another question. But again, if you're an enterprise user, say I want to target a particular thing, there's some really cool organisations doing some really cool secure phone call stuff, secure encrypted thing using TrustZone to encrypt end to end. Now, where it's really, really, really cool for the average developer is that you begin to see the operating system or people using those features to provide secure functionality. So the Keystore should be backed by the hardware security of TrustZone. That would be a nice thing to do. So I think the future there for us is that these technologies will be used to provide more generic OS features which you can then hook into, and because they're the secure OS features, they can only be done by real OSs. So it's another way where you don't need to worry too much about rootkitting. If you have a Knox-based Samsung phone and you're using the Keystore, those are hardware-backed keys. There is no way for you to get that memory back without doing something like a cold boot or a data probe or something like that. They are really, 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 really powerful. But they are hit and miss, and they're not the same on every device. And even things like if you go into trusted development, the size of the trustlet you can build onto, push onto different devices differs. And it's getting better, it's getting more standard, and as every phone comes out, it is getting much better. But it is quite a niche product, it's quite an advanced product, but people should be aware of it. Whiteboxing. Whiteboxing. So whiteboxing is probably the coolest bit of tech, and this is the penultimate slide, so I left it to last because it's the most affordable high security thing you can do. There's basically two types of whiteboxing, and on my security graph I had them both. There's generic whiteboxing where you can buy from an organisation or acquire from an organisation a crypto function which is already in a whitebox, i.e. storing keys in a particular way. It's got obfuscation built in. And the way these generally work is they're generally virtual machines. That they are like a definition of instructions, and as the process runs, it modifies the virtual machine to say, okay, a virtual machine is basically set, if you see this thing, convert it to this processor code. So it's like a mapping table, and then you have the code you're going to run. As that code runs, it modifies the virtual machine. So an instruction or a bit of binary here, which on this line means add two numbers together. Down this line, further down, it means divide two numbers. So you can control you can change it. So if you're looking, static analyzing the script, you don't know what the script's doing without actually running it through the virtual machine to see how it's manipulated the virtual machine. Really annoying. The great thing about whiteboxing is it ties in with your binary protection, so you need to have both. So with the whiteboxing, what you can do is you basically develop atomic functionality, and they have to be atomic because you can still do side loading attack, i.e. if I can nick your whitebox out of your app, I can then put it inside of another app and call the functions from the side, because your binary protection only protects to make sure the whitebox hasn't been modified itself. The second thing about whiteboxes is though, what they generally do is they take your script that you've written and then they rewrite that script in 100 different ways. So you're never quite clear what the script actually is doing. So it makes 100 lines of assembler into 1,000 lines of assembler. And you're sitting there going, you're following this through, it's doing jumps all over the place, but also there's bits of code which are repeated over and over, and you're not quite sure they are. So by adding a whitebox in along with binary protection, and if you have a custom whitebox, the generic whitebox is basically saying, I'll do an AES encrypt, and basically you provide an RSA key into it and some data, and it will give you back a encrypted AES key and the data encrypted using that AES key, and you'll never be able to pull out the AES key in the plane in memory. It'll never be in the memory, so it's really, really cool. That's basically the principle of a generic whitebox. A whitebox where you've actually coded it yourself is you've written some C, which is using a function like an AES function, which is compiled into it, will actually turn that entire thing into a whitebox itself. So it means that every whitebox is different. And the reason that's better is because if a vulnerability against a standardized whitebox is discovered, which it will be at some point if it's used by enough organizations to protect enough confidential things, then you find that the everyone who uses that whitebox is hacked. Whereas if you're making your own whiteboxes per app and per app deployment, your cross-contamination attacks are much smaller, so you have to attack every single version of the app that you've compiled to then break into each individual whitebox. You can't quite yet, it's not really feasible because of the way the app stores work, to give each individual person who installs their own whitebox. You can do it because you can download code and execute the code, but it's not necessarily a good idea to do that. So you end up with a situation, what's the best thing? Every time you release an app, you get new whiteboxes. The thing about whiteboxes is they support secret distribution. So let's say you wanted to distribute a server key or a salt or something like that into a client app, and you don't want that exposed. Whilst the sideload attack to call the function which uses that might be there, the key itself won't be exposed. Okay, now you kind of got to trust that that's how it works. You can go into the vendor, go find whitebox vendors and find how that works. But basically, the whitebox that's what they're doing. They're supporting a secret distribution. Now, again, what you can do is you can do something like a proof of work system. So if you want the user to log in, you put the user and password into a whitebox. The whitebox then does some kind of processing function which takes, let's say, 5 seconds on a decent phone. And then the output of that is then sent up to the server, and the server then validates proof of work and then validates that the user and password, decrypts the user and password, and validates that they're correct against the thing. And the reason why that's nice is that anyone coming along and wanting to brute force your server could nick that white box with the secret in it and then run it over and over and over again, but they'll have to actually run that 5 seconds of work over again. So they're brute forcing attack, they'll have to nick a lot of computers, get a botnet to do it. Now there's no saying you can't get a botnet to do it, but the point is your botnets work now working one request every 5 seconds per bot on the botnet, rather than, in those 5 seconds you can usually do 100 requests or 1,000 requests, so you've really slowed down a brute force attack. So that ability to support secret distribution is really quite cool. Also, the organisations that offer these kind of white boxes often other services, such as stuff like the ability to, when you whitebox, because all your code is obfuscated, it can inject things into your code to mislead an attacker. So if you run strings on a binary file, you get back all the strings. It would be really, really nice to have a couple of URLs in there. So a malicious attacker who pulls out the strings, pulls out a URL, puts it in a web browser, see what the URL is, to see if they can attack the server. Well, if you get a hit on that URL because it's a URL which is never called by the app, but it's just in there, strings are pulled out, it's a very trivial way of catching someone out. Now, a really advanced attacker, a government-trained attacker won't do that. And obviously anyone watching this video won't do that now either. I think if they got this far through the video, then they haven't learned anything. So yeah, you can do really advanced stuff, and some of the stuff that the organisation do is really, really cool. So I would go to your whiteboxing vendor and say, what else do you offer? Okay, last slide, and we're done. James's top hints for secure development. First of all, it's a loop. Get a security champion, or be the security champion. Even if you're not a developer, you can be the security champion. Challenge decisions. Say, how is that good? We, for example, we had this great situation. I worked with some great guys, and we played devil's advocate with each other. Someone proposes a solution. The person goes, "What if I?" And you go round the loop. You then go through the process. You go to security. If you're going, "Oh, okay. Well, if you're going to do that, well, you'll get caught by this other part. You'll get caught by this. We'll detect it here. We'll do this. We'll do that." And you modify your solution. So, as a security engineer, if you are someone, get someone who you get on with to really challenge your system. Going, okay, well, what happens if I pass in dodgy data here? What happens if I change these variables? What happens if? What happens if? Really challenge that solution. Do it over a pint of beer, for crying out loud, but be prepared to change your ideas. Be prepared to evolve your ideas and make it better, because making it better is what it's all about. Timely dev process. Review your authorizations. Review your key handling situations. Be accountable to your peers in your organisation. Let people go, I think you made a mistake there. Really interesting. I saw recently that organisations have a very authoritarian style approach, which I know people who knew me years ago. I was a bit more authoritarian, like, oh, what I say goes, sort of thing. But no, that's wrong. They said basically companies do have an authoritarian style from the CEO downwards, where potentially a lot more subjected to, or more likely to be a whaling attack, was more likely to succeed against them, because if they got an email from the boss saying do this, they would do it. That doesn't work when it comes to security. Anyone should be able to challenge it. Anyone should be able to say, I think there's a bug in the system. I think there's a security hole in the system. Now, you should be able to go through that list and go, yeah, okay, it's a big one, or it's a minor one, or it's just not going to happen, or we'll detect it later. We see security holes in some of our products where you sit there going, it's possible to send a request in that our server will accept. And you go, yeah, but the next one that comes in will be rejected. So I often see ones like, any app can call our registration API. But it doesn't mean to say the registration will succeed, or it'll be able to say, yes, I'm an app. But then the next one it goes, yep, are you a valid app? We'll reject it later. So it's okay sometimes to go, yeah, we'll let you get you one through. But for our systems, it's about, you won't actually get a card. You won't actually be able to do a transaction. It won't work at the end. Use security shortcuts. Okay, use existing libraries. Use LDAP for the back-end stuff. Use OAuth. Don't sit there and think I have to do everything myself. Use libraries. There's a one called It's Dangerous. It's a Python library. If I'm sending stuff from Python to Python, It's Dangerous is amazing. I can sign it, I can stash it in a database, I can pull it back later, I know it was signed by me in my code. And designing from day one. Design out potential data leaks, design in security. Do it from day one. Sit down with your team. So what features do we get by doing this? How can we sell this to the product owner? How can we sell this to the marketing team as a better solution? That literally is it. There is no more. And yeah, if you've got any comments at all, get in contact. I'm on Twitter as Jmons. Please let me know what you think. I realise I've gone a lot over the 40 minutes it was. As I said, did this at Nordevcon. Nordevcon is a great thing. I'll put a link in the video below, and I hope you found it useful and helpful. And if you've got any other comments, and also challenge these things, come back and say, actually, there's a better way of doing security. There's a better way. Let's hear about them. Let's improve. Let's become better engineers. Let's do things better. I'm not really a developer anymore. I am more of an architect or a systems engineer. So. And also, it's a rapidly changing world. As I said, Android is getting, and iOS are both getting better and better and better. Every year they're releasing better features. You look at iOS, started by saying you're no longer allowed access to the user's phone number. You've got to use the advertising ID. They started protecting their users' privacy. So they're really great things to follow. I don't think you have to think that security is about becoming a giant crypto nerd or understanding, these very, very complicated mathematical problems, because I don't understand them. And I'm managing to make secure systems. You need to understand how to apply cryptography correctly, but you don't necessarily understand how it works under the hood. So yeah, get in touch, hit like, Don't bother subscribing to this channel because I don't post it very often. It's my personal one. But yeah, if you've got any questions, hit me up in the chat or hit me up on Jamons on Twitter. I found a lot of people, whenever I post a video, I get loads of people talking to me on Skype or on LinkedIn or something afterwards. Very few people are like to comment in the chat, on the YouTube chat, which I understand, I get that. But yeah, spread the word, take this advice, go away and think about it. That's really all the advice I've got for you guys today. So I hope you enjoyed it, and if you're around for Nordevcon in the future, please come say hi. I try and turn up to every year. And yeah, just let's make the world a better place, a better, safer, stronger place. All right.